So, secured shell SSH. Earlier in our class, we did the Telnet. Secured shell. So, there's going to be a shell inside whatever kept will be secure. That is SSH. Now, we are going to see how to enable SSH. As I said earlier in some classes, I think the previous class, we mix data with key, public key, so that in the public, when someone sniff our packet, they will not know how to decrypt and know the password. Repeating again, whenever you are doing remote login from a computer to a router or any other device, we are using router, and from this machine you are going to do SSH. The IP address of this port is 10.0.0.1, 10.0.0.2. Let's take it as an example. Now, when I do SSH, okay, first let us talk about Telnet, which we earlier did. When I do Telnet, I'm saying from this PC, I'm saying my source port number, let's say, for example, I'm writing 5555, my destination port number 23. And the IP address and MAC address, everything goes to the router. And the router will see this 23. And it understands that router needs to provide Telnet service. So router says, fine, I'm ready to provide a Telnet service. Can you give the username? Then he types. Next, can you give the password? And then he types. That also goes here. And this router verifies it, and then it reveals, it sends the page, the command line interface to the user, so that now user can type the commands that he want to put into the router from this device itself. So he starts writing the commands instead of going through a console port. From a remote device, he started configuring all the commands that he types. It goes and gets saved to the router. So it is the media in between which is carrying the data. What if someone taps? He will also be receiving a copy of all the conversation between this computer and the router. It is called as man in the middle attack. If anyone in the middle can gain the access to the data which is going between party A and party B, then we call it as mitigation, man in the middle. So between this PC and the router, anyone can see what they both are talking. A simple solution to stop this is use SSH instead of Telnet. When we do that, the logging. Okay, sorry, I missed one small portion in the previous explanation. So anyone can tapper, anyone can in the middle can see the conversation that is going on between these two devices, I said. This middle guy, he can even see the password which the computer A is using to interact with the router A. So using the same password, he starts listening to the conversation between these two devices. Now what we need to do? We need to protect by encrypting the password so that this middle guy will not be able to see it. If he cannot see the password, then he don't have access to the data that is going in between these two devices. That is the key to see the conversation. So we need to use SSH. When I do SSH, my key will not be revealed to the public. The middle guy, when he tries to see the password field, that password field will be a hash value. He cannot decrypt it because it's not encrypted data. It is not only encrypted, it is hashed. If a data is hashed, there's no possibility of a third person to see the data. Only the sender and the right receiver can see it. No one in the middle can see it because the middle people will not have any knowledge of how to decrypt it. Only the sender and receiver knows how to decrypt. A normal encryption, others can decrypt, but hash not possible. Why? Because there is a public key involved. To make it simple and easy to understand, let me tell you this. Let me call this as PCA. PCA wants to take router A remote by using SSH. So from PCA, we do SSH to remove the router A. What router A will do, first it will say, welcome PCA. I'm very happy that you want to do SSH, but here is my public key. Keep it with you. Next, answer me this. What is the username? And you will type username. It goes to the router. Next, what is the password? Now what this PCA will do, because it is an SSH session you are trying to establish, it will use the public key given by router A. Pub key. Using that public key, it will encrypt and hash the password. and only the hash value, which is encrypted and hashed using router A's public key, will be sent. Now, if the attacker in the middle tries to see, he will not be having that knowledge to decrypt it. Why? Because the public key is not known to anyone in the world. Sorry, public key is not given to this guy. It is only given to this PC who wants to do sessions. But again, because it's a public key, if he tries to know the public key, he can know after a long struggle. By the time the session would have got over. Even if he knows the public key, what if this attacker got a copy when the public key was given to the genuine? The public key is given to the genuine, but in the middle, at the same time, the attacker is also getting the public key. Same time. Then you may think like, okay, he will now use the public key and try to know the password. No. Why it is not possible? Even if attacker knows the public key of router A, whatever PCA hash with the public key of router A and sends, only router A can reverse it. No one can reverse it in the middle. Only router A can decrypt it. How? Because anything that is hashed using the public key will be reversed by a private key, which is not given to anyone. Router A gave one part of the key called public key to PCA to hash the data and send. To see the hash, one needs a private key, which is not at all exportable, which is always local. Router A only knows that private key. Router A will have generated two keys at the same time, public key and private key. It gave the public key, but it did not give the private key. So only the one who holds the private key can decrypt the hash. So even if the middle guy knows the public key, he cannot reverse the hash because he don't have the key to reverse it. So there is no use of having the public key. Attacker has got no benefit of knowing this public key. So a total security you see between this PCA and PCA and the router. Now, one thing you should have understood: SSH is secured remote login. Telnet is insecure. SSH, when someone does, there is no chance of middle guy, intruder, to spoof like a SSH client. See, this is the original SSH client. No one can spoof like the client and talk to the server. Not possible. So SSH is secured. For this, we need to generate a key. This is what I want to tell you. We need to generate a key. The key is two pairs. Sorry, it is a pair. Public key and a private key. Public key will be shown when you type the show command. You can see even the public key. And public key will be given to whoever wants to do SSH. So that they can use the public key and encrypt the data, hash the data, and send it to us. Only those who have got the private key, which is not revealed to anyone, even to us. We are the one who is going to generate the key, but it won't be revealing to us. The device will keep it for itself. Only a public key you can see in the show command. I will show the public key how it will look like. And only the public key will be sent to the one who wants to log in. Safe. But again, SSH compared to Telnet, it's going to take additional time and process because it has to hash, generate the key, and a lot of things involved. See, obviously the time taken and process utilization is going to be more. Checking in some airport takes long time because they have 7 layers of security. Some airports like Afghanistan, if you need to check in, better you go like 4 hours before. 7 layers of security you need to pass. It's not like European countries. In European countries, if you are in transit, not even scanning in, you just walk through one small tunnel. That's all. No one scans you manually. Nothing. So transit becomes easier. No time taken. More the security, more time taken. So where are we?
I have a quick question.
Yes.
So what is the difference between the encryption and the hash value?
Encryption is this encryption is just you take a mixture of sand and some fine powder of gold. You want to make sure no one identifies there is a gold, so you take some quantity of sand and mix with the gold powder and you send it. When someone opens, he see only the sand inside. But the receiver knows sand is mixed with this gold inside. So we need to extract sand from it. So he put it into the extractor. It separates sand and the gold comes out separate. This is encryption and decryption. Mixing sand on the other side, the person knows that sand has been mixed. We need to remove the sand. Like sand, we have algorithms. AES, DES, triple DES. These are all encryption algorithms. Everyone knows. So if I want to know some data, I can use triple DES and see whether I'm able to see data. Something you can do, but again, that is also not that easy to decrypt someone's packet because session ID, many things are involved in that. But decryption is possible after long struggle. You can somehow decrypt someone's packet, but hash cannot be reversed without a private key. Because private key is not like an well-known algorithms. AES everyone knows. DES is one algorithm for encryption. Triple test is another algorithm. Everyone knows it. So they can somehow manage, but it won't happen immediately. Even if they decrypt, when they decrypt, there won't be use of that password or information, because by the time you decrypt, it's like 2 years later you can finish decrypting EAS packet. It will take at least 1 year for you to decrypt. By the time there won't be use for the decrypted value for. Mm. So what I'm having to say is, again, it depends on how strong the algorithm is. There are different algorithm, different size of algorithm in AES. 128, 256. More stronger, more time it will take to decrypt. But hash, that also not possible. Why? In order to decrypt the hash value, you need a private key with you. Only a original genuine server will have the private key. That private key is not involved in encryption and decryption. Sorry, the private key is not, yeah, correct. The private key is not involved in encryption and decryption. It's only involved in hashing. So it is one step more stronger encryption and decryption. But some people uses the same word encryption and decryption for hashing also, because it is easy for us to explain. Hashing, reversing the hash. It is little difficult to say, so some people say encryption, decryption. Again, I'm not denying, yes, it's decryption, but there's a private key involved in it, which is not there in encryption. Yep.
Yes.
Right. So now we are going to quickly enable SSH and do SSH. I'm on the topology where we were earlier. Currently, sorry, if I log in and see telnet, telnet 10001, it's asking username, I think 123 I gave. 123, no, 123, sorry, ABC. What? Okay, now this is a chance for us to know how to recover the forgotten password, right? We are going to see how to recover password, because I really forgot password. I know one of you will remember the password, but still let us not use the password. Pretend, you also pretend, but I'm not pretending, seriously I forgot. You pretend as if you've forgotten the password. All those who have seen the previous video knows the password. Now, after I turn off the router, as soon as I turn on, I need to press Control Pass Break key. There's a key in your laptop. Some laptop will have Insert Pass next to the delete button. Insert Pass, P-A-U-S-E. In a big keyboard, you will see Pass Break key. So I need to press that. See, I off it, I on it. While it is booting, Pass Break key. That's it. You see, I'm entering into a mini boot mode, a roam on mode. Meaning I have interrupted the normal booting process. I said don't boot. Why I'm saying that? If I allow this to boot, it will go to NVRAM and take the password, my previous configuration, and then it is going to come and ask me password. Unless I give the right username and password, it's not going to allow me. So I said, better don't boot, man. I don't know the password. Why you do that? Boom. I stopped it. And now If I bypass NVRAM lookup, if I bypass the startup configuration lookup, the router will not ask me the username and password. Why? Because only in the NVRAM you got that username and password. If I bypass it, the operating system will get decompressed into the dynamic RAM, DRAM. In the DRAM, the operating system gets loaded and I will be seeing a new fresh router now. Why? Because the NVRAM is not loaded. NVRAM is not loaded. So it will be like a new fresh router. And then what I can do is from the logged in command line, I can say show me startup, show me the NVRAM. And there I will see this password that we configured earlier. To do that, to bypass NVRAM, what I have to do is first, say put question mark if you don't remember the command like me. And this is what the command that I need: configure registry, CONFREG 0x2142. This is the registry value you have to type so that operating system will bypass NVRAM. The default is 0x2102. This is the default. If this is the register value, it will load the NVRAM. But I don't want to load the NVRAM, so I want to bypass, I say this 0x2142. You need to remember this number. And now after this, you can say boot. You will see now, it will ask me a question, should I configure using dialog? That means, see, it's not asking me username and password. It says, I will allow you, just tell me you want to do, because I don't see any basic configuration. Do you want to use a dialog? This you will see only if NVRAM is empty or NVRAM is not seen by the process. The process have bypassed NVRAM. That's why it is that. Now, I don't know the password, but I'm able to log in. That's what we want. If I am logging in, then I can say, show me the startup configuration, not running configuration. Start. Meaning, I'm saying, whatever is in NVRAM, show me now. Let me see. I can see the password and username now. After knowing the password and username, I need to go back to normal mode. This is bypass mode, you see. Show version. You see, it's a bypass mode, 0x2142. I need to go back to the normal mode. For that, here itself you type config registry 0x2102, which is the default. After giving this, means I have changed the registry value. I no need to do again mini boot mode control pass break. I can do it from the global configuration mode like this. And now I'll go out and or I can reload physically also, or you can say reload there also. Now it will load the NVRAM and you already know the password. You see, it is normal mode now. I'm going to use the word China, India, Yeah, I have logged in. I have logged in. Now we will tell it one more time from here. Username is China. Password is India. But the problem with this is if I try to say enable, it will say no. For security reason, I need second level of verification. See, in console, you don't have a problem because console is local to the router. When I type enable, it is not asking password. But someone is doing remote now. Because he gave the first password correct, it is not going to believe us. Because we have given the username and password correct, it won't believe us. Because this after enable mode, someone can go and spoil the router if he's a wrong guy. So it wants to verify that the user who has logged in is really genuine. So there is a second level verification in SSH and Telnet. But we have not enabled that. We need to enable. So to enable, we are enabling the second level verification. This will be now, after we enable this, it will be even applicable for console. Enable password 123. Now, even in console, if you go out and come in, India, China, you see here it is asking password even in console because I have set it. Now in the telnet, if you go and type enable now, it is not saying not set, it is saying give me the password. It is already set. 1, 2, 3, boom. See, someone can see the console command prompt, global configuration mode. I can go to global configuration mode from here now. Because two level of verification is successful, it understands that you are genuine. Next. We need to enable SSH. For that, I'll go here and create. Before that, you need to give a domain ID. Domain yeah, IP domain name. Give any name. I'm going to say domain name as CCNA. Some people will say ccna.com, .in. I don't know why they do this. Simply to say domain, because the word domain is coming, they use web domains. .com, .in, and .us. Okay. Now, next what we need to do is we need to generate a key. So using
So domain name is like a database?
it will group devices which has got the same domain name for grouping.
Okay.
Now, when I generate a key, it is going to use this host name and the domain name, and it generates a key, the public and private key. You see, crypto key generate RSA key. RSA is an algorithm, and you need to define a size. It is asking the default size of RSA algorithm I'm going to use is 512 bits. I was telling about a sand, you mix sand. 512 kilogram of sand you are mixing. See, ra.ccna. Ccna is a domain name. RA is a host name. This is also used along with the sand to generate a key, public key and private key. Now it is asking, do you want to use 512 kilogram of sand? See, more the sand, more difficult for someone to know that there is a gold inside. So I can say 1024. If I say 1024, you are enabling SSH version 2. More strong you make, the latest version will be there. I hit enter. So it says generating 1024 bit of RSA key. Key will be non-exportable. Fine. That's okay. Now you see it will say SSH version 2 has been enabled. I'll show you. Show crypto my crypto key my pub key. My pub key RSA. This is the public key which is generated for us. You see the key name. This is public key. Private key you cannot see. This is the key that will be given to someone who wants to do SSH. This is the sand that I was talking about. There is other side of the sand which is an extractor private key which is not revealed to anyone. It's within the router. Even we can't see it. When a hash value comes, it will use that key to see what is inside. Now, I need to tell someone when they remote, I need to tell the router that you need to use SSH, not the Telnet. How to do that? For enabling Telnet, we went under line VTY 0, I think I gave 1. Means two people can simultaneously Telnet, 0th session, first session. You can increase up to 0 to 15 if you want. We want SSH. So for that, transport input telnet, I would like to cancel. That's what we said earlier. I said I don't want anyone to do telnet. Now if you go on telnet, it will not be possible. Let me exit from here. Now I use the same. Why? Okay. I use the same IP address. See, it's not allowing me. Closed by the foreign host. Because I said no telnet. Instead, I'm going to do SSH. Transport input SSH. Fine. See, it's the same username and password that is going to be used. Show run. These are the usernames that we will be using. Now, I'll do SSH from here. See, SSH in real world, what we do is we use this putty. You click on this, you put the IP address, and the port number is 22. And we say open. That's how we do SSH. But
That's the client, right?
Here I don't have a client software. It's a simulator. Let me check whether I have any. any other option to do SSH dialog. I don't have an option, so I need to use the commands. SSH -L. L means login to the address 10.0.0.1. Welcome. SSH I'll do one thing. To make it simple, I'll delete this computer. Instead, I'll put another router as a client because I know commands in the router. I don't know the Windows commands. I'm not teaching Windows. I don't want Windows. So, simple. Whatever the IP address I had in that computer, I will put into the router. Now, first let me ping 10.0.0.1 from here. This is a computer now. We have replaced them. Now I can do SSH. See, SSH-L means login, and then the address is 10.0.0.1, and then the username is China. What? It's asking. It's searching for China. Wait, I should not type China here. See, whenever I make mistake, it will take it very serious and think that that's a command I'm typing. So it is searching for that meaning of China. It is searching everyone. Do you know anything about China? It is doing broadcast. No one is going to respond, and it will time out and come out.
There's a command that helps doing no translation.
Yeah,
Right?
yeah. No IP domain lookup.
Okay.
We'll do later those things. I've not covered that, so I don't want to use it now.
Brother, இப்போ இந்த ரவுட்டர்ல இருந்து அந்த பிசி பிங் ஆகுமா?
What?
20.0.0.2.
Why not?
Okay.
Why not? From this router, right?
Yeah, from this router, this PC.
Yeah, we need to write a default route so that it will go to
Okay.
PC. I'll show you that also. Okay, now SSH. Let me cut this China and hit enter. In command, okay, put question mark and see what is version is missing. We are using version 2. Version 2. Wait, SSH -L. Okay, login name, not the IP address, the login name. China. Version 2. And then what is the IP address we are doing a search? 10.0.0.1. Version 2, enter. Oh no. Version 2 it has taken as IP address. Okay. Instead of waiting like this, off, on.
நார்மல் SSH கொடுக்கும்போது டைரக்ட் ஐபி அட்ரஸ் கொடுத்து லாகின் பண்ணுவாங்க brother.
Depending on operating system.
Device to device, okay.
SSH-L. I need to give the login name is China. And then I have to say -V version 2, and then the IP address 10.0.0.1. Enter. Yes, it says open. SSH is open, and give me the password. By this time, the public key is already received by this client. The client is already having this public key now. So using that and the password that I'm typing now here, India, see, it has taken me inside there. I can see the router. I can see the server, the client, the SSH server, the router from this client. So from this PC, this is instead of PC, I put this router. Just see this. Enable 1, 2, 3. I'm in. Now you can go and ask this guy who has logged in. Show SSH. It says there is someone with version 2 has logged in. AES 128 algorithm hash shell SSH session started. Channel fully secure. You will not know anything other than this. Right. So mode in and mode out both are successful. In and out communication is happening. SSH is happening.
I missed the command. It's the transport input SSH.
Yeah, I'll show you that also. Show run. You see, transport input SSH.
Okay.
Now, let me exit and show. Now, if I ping from here, show IP route, I don't have route to reach 20. If I need to ping that remote computer, if I need to ping from this router to this computer, I need a route. In the computer, we used to have default gateway, but here there is no default gateway because I have used router instead of computer for testing. So write this IP route. I have not delivered these static route topics so far, but because you asked, Brother Ramesh, I'm doing this. IP route, any network, any subnet mask, send it to router 10.0.0.2. Is it 1 or 2? 1. Now, come on. I delete this and I put the right one. Okay. Now, if I check show IP route, I have a default route. You see, gateway is who? 10.0.0.1. I have set the gateway. Now I can ping 20.0.0.2, 20.0.0.20. Yeah. If you don't have the default route, not possible. See, let me remove this. See, there is no default route. Now try pinging. The ping won't happen because the router don't know the route. We are going to learn these things properly in coming days. But just to answer.
Okay, sure. Thank you. Thank you.
Welcome. So